Welcome back. Today we're going to be working on 8.5 Day 1 notes, solving quadratic equations using inverse operations, which is stat math. Before we go ahead and begin though, let's review what we talked about in the last video. So we're going to be solving the following quadratic equations by factoring, if possible, because remember, not every trinomial or binomial can be factored. Alright, first rule, let me zoom in real quick. Let's look at number 1. If you recognize it is not set equal to 0. So before we go ahead and start factoring, I have to move everything to either the left side of the equal sign or the right side of the equal sign. Now we figure that out if we look at the quadratic term. That's that term with the exponent equal to 2. That has to be positive. So since 3b squared is already on the left and it's positive, we're going to move everything to the left. So we'll move negative 7b over to the left, we'll do x. Here, since 20 is on the right, we're going to subtract to get over to the left. Now, if you recognize 3b squared, 7b, and negative 20 are not like terms, you cannot combine them. So we're just going to write them in the correct order, so stated form. First, put 3b squared plus 7b minus 20. Don't forget the equal sign drops down. And then everything equals 0. Place that. And send the door. There we go. Do not forget the equal 0. That's important. All right, from here, always check for a GCF. There's no GCF, so go ahead and factor. If 3b and b, everything that makes negative 20 is negative 1 and 10. Negative 2, negative 1 and 20, negative 2 and 10, and negative 4 and 5. Now, since there's a 3b in front, we don't know which combination we'll be working with, so we're going to have to check those inners and outers. Double check. And don't forget the equal 0. Let's see what is this going to be. Let's try positive 4, negative 5. Again, let's just check our inners and outers. That was just a guess. Negative 5 times b is negative 5b. That's 12b. When I add those together, I get 7b, which is exactly what I got. Again, this is not my answer. Now I have to continue using the zero product property. So again, I have 3b minus 5 times b plus 4. When I multiply those two together, I get 0. So what do I know? I either know 3b minus 5 is equal to 0, or I know b plus 4 is equal to 0. Once I solve those two equations, I get my two solutions. So add 5 to both sides, and b is equal to 5, divided by 3, so b is equal to 5 thirds. Here I'm going to subtract 4, so b equals negative 4. So my two solutions, b is equal to negative 4 comma 5 thirds. Okay. I'm going to go ahead and skip number 2. You are still going to be required to do number 2 to get your full 10 points from this section. I'm going to move on to number 3. Again, let's go ahead and draw a line over the equal, under the equal sign. And if you recognize, this is clearly not set equal to 0. So from here, we're going to look at two quadratic terms. What do? You always move the smaller one. So you're going to move x squared over to the left by subtracting it. We're going to put it right under that 7x squared since they're like terms. I'm going to subtract 3, and again, I'm going to put it right under 3 on the left because they're like terms. And lastly, you're going to add x both sides. And again, put it right under that negative 4x since they're like terms. 7x squared minus x squared is 6x squared. Negative 4x plus x, negative 3x. 3 minus 3, that's nothing, drops down the equal sign. Everything cancels on the right, so 0 drops down. From here, always check for GCF, and you should recognize that both those are divisible by a 3x. We're going to pull out the 3x out in front and now divide. 6 divided by 3 is 2, x squared divided by x is x, minus 3 divided by 3 is 1, and the x's, there's a tie. So you remember from the last couple of videos, what do we do with this 3x? Remember 3x times 2x minus 1 equals 0. We're actually going to set 3x equal to 0. We're not going to ignore it since we have variables. And I'm going to set 2x minus 1 equals 0. If 3x equals 0, when you divide by 3 to both sides, x is equal to 0 divided by 3 is 0. Here, add 1 to both sides. 2x is equal to 1. Divide by 2, x is equal to 1. Okay? Our two solutions are 1 half and a 0. Alright. If you notice, number 1 and 2, after setting each equation equal to 0, all the equations end up being in standard form. Remember, standard form ends up being ax squared plus bx plus c is equal to 0. So each equation ends up having a quadratic term, a linear term. That's going to be really important today when it's just as an x, that's my linear term, and a constant. Even though in number 3, I didn't have a constant, my constant was 0. Okay. Before we actually move on to what we're learning today, let's quickly review from Unit 1 how to solve equations when they're solving using stacks. So first thing you should always ask yourself is, can you simplify? Do you combine any like terms, or can you distribute? No, so you're going to go straight into sadness. That means we have to cancel everything that's adding or subtracted first, then multiplication, division and multiplication, exponents, then parentheses. So here, we're going to add 3 to both sides, because we are getting rid of the subtraction part. So 2x plus x equals 10. Now, let's move on to getting rid of everything that's multiplied inside it. Well, it's 2 times x. So that's the opposite, the inverse. So divide both sides by 2, and it's going to equal. Again, these are solving linear equations. Today, what we're going to learn how to do is solve quadratic equations using the same type of same method, StatMath. All right, let's move on to 5. Again, you should always ask yourself, can you simplify? So can I simplify means can I combine any like terms, or can I distribute? And I can distribute here. I'm left with 16b minus 16 equals 48. Once you end up combining like terms, once you end up simplifying, meaning you distribute here. Follow that. Let's cancel everything that's being added or subtracted. Well, I have minus 16, so you cancel that by adding. I have 16b drop down, and that is going to equal, let's say, 64. And then I already canceled everything that's added or subtracted, but I'm going to move on to multiply and divide it. So I'm going to go ahead and divide by 16 both sides. B is going to equal 4. All right. Now, if you notice, on both of those questions, I only had to cancel everything that's being added or subtracted and dividing and multiplying. I actually never got to exponents or parentheses, and that's what we're going to be doing today. So we're going to start by still saying cancel adding and subtracting first, and move to multiplying and dividing. Now we're going to learn how it means to cancel everything that's exponent. But before we have to cancel the exponent, I need to know what the inverse of something is. The inverse of squaring something, remember x squared, I have to learn how to get rid of that quadratic term. How do I get rid of the exponent of it too? Well, we do that by taking the square root. And the square root is this symbol. You should have already seen it on your calculator. So remember, the inverse to adding is subtracting. The inverse of multiplying is dividing. The inverse of x squared, squaring anything, is square rooting. Now, we are only going to use this, I like to call it the square root method, when there is no linear term. Remember, I said that before. It's going to be really important today about noticing if there's a linear term. So remember, the linear term is just the term that just has x to the first to it. Just x to the first. If it has x to the first, so it has a linear term, we're going to keep doing what we've been doing in the last couple of videos. Solve by factoring, like what we did on the first two examples. But if there's no linear term, that's why there's a big x there, versus the quadratic and a constant, we are going to solve using the square root method. Here are the steps. The first thing you're going to do is isolate this quadratic term using StatMath. You're going to cancel adding or subtracting, then multiplying and dividing. Once we get that x squared by itself, then we're going to take the square root of both sides to get rid of everything with the exponent. Then you have to remember you are going to have two solutions, meaning, for example, if I have x squared is equal to, you know what, I'm going to stay outside this box. If I have x squared is equal to 9, look, my quadratic term is already isolated. So I'm going to take the square root of both sides. In your calculator, look, the square root and the square cancel, so you're just left with x. When you put the square root of 9 in your calculator, it just comes out 3. But remember, if I square 3, we already know that gets 9. But in your calculator, if you square negative 3, that also gets you 9. So you have to remember to remember your two solutions. Your calculator is never going to give you the negative solution when you take the square root, so just remember. So my two solutions are 3 and negative 3 for that example. Okay. All right, let's go ahead and do some examples. Again, we are checking for a linear term, so that is why that is when you know when to use the square root method. So let's look at number 1. Notice I have a quadratic term, and when it's just a number, there's no variable, no letter attached to that number, it's a constant. So there is no linear term. Remember, a linear term would look like this, 5x, anything that has an x to the first attached to it. But since there is no linear term, we're going to do the square root method. So the first step is isolate, so get the quadratic term by itself. So look, the quadratic term is already by itself. So I got to get the exponent of a 2 away from the x. So I do that by taking the square root of both sides. The square root and the exponent of a 2 cancels because they're inverses. Remember, when you take the square root of 4 in the calculator, it's just going to be 2. But don't forget about your two solutions. You're going to have positive and negative 2. Now, remember, you can write it as negative 2. I'll accept both. Let's go ahead and move on to 4. Then, let's go ahead and start reading StatMath. S slash A, D slash M, D. Okay. Now, we have to figure out if we're even using StatMath, or are we going to factor? Remember, StatMath is going to be the square root method. We have a linear term. Well, I see a quadratic term, because the exponent is a 2, and I see a constant. The answer is no, I don't have a linear term. Yeah, a linear term would look like this, 6w. Since there's not a term with just a w attached to it, I know I'm going to go straight to StatMath. Under StatMath means you isolate the w squared term. You got to isolate the quadratic term. But here, I have to cancel everything that's being added or subtracted first. So look at this 5. That's not being added or subtracted. I'm going to go straight to canceling everything that's multiplying and dividing. So how did I get rid of the 5? By dividing. So now the w squared is equal to 12. I canceled everything that's multiplying and dividing. Now I'm going to move to everything with the exponent. So how do I get rid of the exponent? I'm going to square root both sides. Under the square root and the square cancel, so I'm left with w. And you put the square root of 12 in your calculator, you're going to get 3.46 if you round to the nearest hundred. But remember, you have two solutions. It's the positive and negative solution. And then lastly, let's go to number 3. All right, again, I see a quadratic term, and this is a constant. So there is no linear term, so I'm going to go straight to StatMath. S slash A, D slash M, D, P. Well, anything that's being added or subtracted. So I just have x squared. I don't have anything that's multiplying and dividing. So I'm going to go straight to getting rid of the exponent. So how do I get rid of this 2? You're going to square root both sides. Square and the square root cancel. Now, if you recognize when you put the square root of negative 12 in your calculator, you get an error. That's because you can never take the square root of a negative number. So this would be a no real solution. This would be an example of a parabola, the U-shaped graph that does not have any x-intercept. Remember, the solutions come from how many times the graph intersects the x-axis, how many times it touches. So this would be considered a no solution graph because there's no x-intercept. No real solution. All right, let's flip it over. Let's do some examples. Number 5. Again, you need to look for if you have a linear term. During with whatever answer you decide, that will figure out if you're factoring, what we did on example 1 or 2, or do the square root. Well, look, I have a quadratic term. 6 is a constant. 6 is also a constant. Remember, if there was a linear term, it would look like this. 6x. But since there's no linear term, you're going to solve this by using that. Okay? So first I have to cancel everything that's being added or subtracted. Oh look, I have this positive 6. So how do I get rid of positive 6? By subtracting 6. X squared is equal to 0. I cancel everything that's added or subtracted first. Oops. Now I'm going to move everything that's being multiplied and divided, but I don't have anything that's being multiplied or divided because I already isolated my quadratic term. Okay? So now I have to get rid of my x squared. Okay? How do I get rid of the exponent? By square rooting it. Oops, that looks like a c, it's really a 0. Now when I put, remember the square and the square root cancel. When you take the square root of 0, you get 0 in your calculator. Is there such thing as a positive 0 and negative 0? No, it's just 0. So anytime you're taking the square root of 0, you're just left with the one solution as x equals 0, because there's no such thing as positive 0 and negative 0. Okay? Let's go ahead and look at number 6. Again, you have to figure out what solving method you're going to use. Either factoring, like example 1 and 2, or StatMath. And the answer is, does it have a linear term? You need to answer that question. Well, I see a quadratic term. Negative 7 is a constant because there's no variable attached to it, and 11 is a constant. So I have a quadratic and a constant, which that means since there's no linear term, you're going to do StatMath. S slash A, B slash N, E. Let's go ahead and cancel everything that's being subtracted. We'll look at this side with the n's. I see negative 7. So I'm going to add 7 to both sides. We're left with squared is equal to 18. I cancel everything that's adding or subtracting. I don't have anything that's being multiplied or divided because if I did, the number would be touching the m squared. So now I have to get rid of the exponent. Well, the inverse of squaring is square rooting. Square root and the square cancel, so you just left with m. When you put the square root in your calculator, after rounding to the nearest hundredth, that's the decimal places, you get 4.24. But don't forget, you're going to have your two solutions. All right, let's move on to number 7. Again, you need to answer the question, do you have a linear term in order to figure out if you're factoring or using StatMath, the square root method? All right, well, I see a quadratic term because it's m squared. I see a negative 5, which is a constant, and I also see which is a constant. Remember, if I did have a linear term, it would be negative 5m. That would be a linear term. So if I don't have a linear term, we're going to solve this equation by using StatMath. We'll start S slash A, B slash M, E. So again, go ahead and cancel everything that's being added or subtracted. So again, we're going to only look at the side where the variable is at, so we'll be minus. I see negative 5 is being subtracted, so I'm going to do the opposite. So I'm going to add 5 to both sides. Like 3m squared is equal to 8. So I canceled everything that's being added or subtracted. Now I'm going to cancel everything that's being divided or multiplied. So I see a 3 out in front. So how do I get rid of 3? I divide it. So I'm left with m squared is equal to 6. I canceled everything that's multiplied and dividing. Now I'm going to get rid of the exponent. How do I get rid of the square? By square rooting. Under the square root and the square cancel. So left with m, but again, don't forget your two solutions. The square root of 6 in your calculator ends up being 2.45. Please go ahead and pause the video to complete number 8. All right. Hopefully that b is equal to positive 3 and negative 3. If you did not get that, please raise your hand and have your credit recovery teacher come up and help you. All right, let's move on to number 9. From here, again, always check to see if you have a linear term. Determine if you're going to be factoring or set, if you're going to use sat map. Here I see a quadratic term, a constant, and another constant. So what does that mean? I'm going to solve it using sat. From here, let's cancel everything that's being added or subtracted first. So I, again, look only at the side of the x is 8. What do I do to put it numbers that 8 to both sides? So 9 squared is equal to negative 54. Now I'm going to move everything that is dividing or multiplying. Well, I have 9 times m squared, so to get rid of it, we have dividing by 9. If squared is equal to negative 6. Now we're going to move to everything that's being, we're going to get rid of the exponent. We're going to get rid of the squared by square rooting both sides. Square root and the square cancels, we're left with m. When you put the square root of negative 6 in your calculator, you get an error. That's because you can never take the square root of a negative number. So what's my answer? No real solution. Okay? If you notice, when we solved in SADMAP, we stopped at the x. Now what we're going to do is move to the parentheses. Let's look at number 10. Anytime we see parentheses squared, that is this. If I have x minus 3 plus 2, let's say equals 0, we're just going to do it by setting that x minus 3, x plus 2 is equal to 0. So in number 10, see I have the parentheses squared. Anytime I see the parentheses squared, I'm going to use that map. Okay? So the goal is to get this x, the parentheses by itself. So if you notice, there's nothing in front of the parentheses or outside the parentheses. Okay? So since the parentheses are by itself, you're going to have to get rid of the square first. So how do I get rid of the square? By square rooting both sides. Under the square root and the square cancel, so there's x minus 3 when you take the square root of 1, remember it's positive 1 and negative 1. Well, here's a linear equation. Do you know how to solve that? Well, let's separate into 2 to make it easier. I have x minus 3, that's going to equal 1, and then my other equation, I have x minus 3 equal to negative 1. Solve both equations. Add 3 to both sides. X is going to equal 2. 4, sorry, I just said that. And here, x is going to equal positive 2 because you're going to add 3 to both sides. So my solution careful, but you don't have a plus or minus with the 4 or the 2. The plus or minus only happens when you take. All right, let's go ahead and move on to number 11, and we're almost done. All right, if you notice, again, I see a parentheses square. My goal is to get the parentheses by itself. But now I have this one. Okay, let's go ahead and stop that, right? I like to get rid of the 2. Anytime a number is touching the parentheses, we know it's multiplication. So I don't have anything else to subtract. I'm going to get rid of the multiplication. How do I get rid of multiplying by 2? By dividing by 2. Okay? 32 divided by 2 is 16. 16 plus f plus 4. Now let's go ahead and get rid of the exponent. So how do I get rid of the square? That's easy. Square root both sides. The square root and the square cancel. So left with, don't forget, 16 is either positive or negative 4, equal to just x plus 4. Right? Now we're going to separate into two equations. My first equation is going to be x plus 4. So that's going to equal 4, because one of them is going to be positive 4, and then I have x plus 4 equal negative 4. Solve both equations. Subtract 4 to both sides, x is equal 0, minus 4 to both sides, x is equal negative 8. So my two solutions here are going to be negative 8 and 0. Now remember, the plus or minus isn't going to be with the 0 and the negative 8. The plus or minus only happens when you take the square root of 16. Alright, last question, number 12. So again, look, I see a parentheses square, so no, I'm going to follow that. Okay, so we're going to look at where the parentheses are. The extra numbers, I have negative 2 and positive 11. So don't forget, sadness says I have to cancel after subtracted first. So I'm going to subtract 11 to both sides. 3 minus 11 is negative 8. Is negative 2 parentheses x plus 2 squared. Now, don't automatically say it's no solution since there's a negative. In order to say there's no solutions, you have to take the square root of a negative. We're not even at the square root part yet. From here, we're going to cancel everything that's being multiplied or divided, and here I have negative 2. Well, to get rid of negative 2, I'm going to divide. When I divide by negative, I get a positive 4. So now with x plus 2 squared. Now I'm going to go ahead and get rid of the exponent. I get rid of the exponent by square rooting both sides. Then with the square root and the square cancel. When you take the square root of 4, it's positive and negative 2. What drops down is x plus 2. Now separate into your two equations. You have x plus 2. One of them can equal positive 2. And then you have x plus 2. The other one can equal negative 2. Last, solve the equations. Minus 2 both sides, x is equal 0. Subtract 2 both sides, x is equal negative 4. Right, solutions are negative 4, comma 0. Please go ahead and attempt the challenge question and stop the video once you're done to complete your homework.